Hello everyone. I am Assistant Professor Dr.Harshal M from Department of Chemistry, SICS Degree College of Bachhav. Today I am discussing on the organic reaction mechanism part and organic reaction. What is organic reaction mechanism? So very simple. That is the conversion of reactant into product. Okay, but how the product is formed from the reactant? There are various ways to form the products, and that is nothing to understand and to study the ways how the reactant is converted into product through which path. That is nothing but the reaction mechanism. For reaction mechanism, nucleophilic substitution reactions, electrophilic substitution reactions are the common reactions. Among them, nucleophilic substitution reactions are widely used in. Now, today we are in connection with this. Today we are going to discuss on the neighboring group participation. So, what is neighboring group participation? Before going to this, let us have this some basic recapitulation. That is just simple revision. That is the SN2 reaction. Okay, in SN2 reaction, that is the substitution nucleophilic bimolecular substitution reaction. So in this reaction, what happens? This is the nucleophile. This is the your primary alkyl halide. That is the reactant. So this nucleophile is attacked from the backside of the reactant and backside of the reactant living group. Okay. So this attacked from the backside of the living group. So there is a formation of transition state, and after transition state there is a formation of product, that is the liberation of living group and attaching of your nucleophile. That is, you can say in other words, replacement of weak nucleophile by strong nucleophile. So what is important things? That is the this position of the OH. So position of the OH or position of the incoming nucleophile is exactly the opposite position of the living group, that is the bromide. Okay, so this product is the inversion, called as inversion in configuration. Inversion in configuration, this product is called as inversion in configuration. Okay, now let us look about the SN2 reaction, sorry, SN1 reaction. In SN1 reaction, what's happened? We are taking the tertiary alkyl halide. Okay, this is your tertiary alkyl halide, and when it is treated with the base in presence of water, first there is a formation of carbocation. This carbocation is attacked by the water molecule. Okay, and after attack of water molecule there is a formation of product. So along with this, so this carbocation is a planar in nature, so there is a possibility of the attack of nucleophile, that is the OH minus, from the front side of the carbocation or from the back side. It means you are getting in the product mixture, that is the OH CH3, this is another one, and this is your another one. Okay, so you are getting the racemic mixture. Racemic mixture, it means you are having the 50% of 50% of retention product and 50% of inversion product, so it is called as racemic mixture. Okay, so now this is just about the SN1 and SN2. Just have the brief review of the SN2 reactions. What happens there in SN2 reaction? This is the your second order reaction, and SN1 reactions are the first order reaction. SN2 reaction, one step mechanism. In SN1 there are two step mechanism. SN2 2 represents the bimolecular, so this is a bimolecular rate determining step, whereas SN1 having the unimolecular rate determining step. The product form has the inverted configuration, and in case of SN1 there is a racemization. Okay, so now this is about the SN1 and SN2. So now today's important topic, that is the NGP. What is NGP? That is nothing but the your neighboring group participation. Neighboring group participation, in short NGP. Okay, sometimes many are confused with the this whether this is the rearrangement reaction or nucleophilic substitution reaction, because there is a some internal attack we are going to discuss in the next slides. So just simply understand that is the this is very important point. If the group or atom is migrates, okay, migrates or it attacks to the another position, and after the reaction if it goes back to the its original position, this is not the rearrangement. In simple, if the group which migrates remains permanently in the new position, then the reaction is called as a rearrangement. That is the rearrangement reaction. But in this reaction, you can see this is the your so a one example. This is your alpha position. This is alpha position. This is your beta position. Okay. So what happens? You are having the nucleophile. This is the same reaction as we see in your SN1 and SN2 reaction. But what is the observation? The observation is that instead of inversion like in SN2 or racemic mixture formation like in SN1, in this reaction, these products comes with the retention. They observe that the retention in configuration in the product. So that is the question mark again. How retention in configuration is possible for this reaction, and that is the birth of the concept NGP, that is the neighboring group participation. So what is neighboring group participation? It is the simple definition. Neighboring group participation is an intramolecular effect temporarily exerted by an adjacent group. Neighboring group participation is an intramolecular effect temporarily exerted by the adjacent group. In this case, the sulfur which having the lone pair at beta position having the effect. Okay, so exerted by the adjacent group which directly participates by moving within the bonding distance of the reaction center and then reverts back. Means after reaction, these molecules goes back to its original position. So this is the simple definition. You can see here how this, suppose these are the lone pair of electron. So it attacks on this carbon. This acts as your internal nucleophile. This Cl will liberates as a Cl minus, and after that there is a formation of, there is again the in the second step attack of this another nucleophile. So you are getting on the same position new nucleophile. Okay, so but this reaction you cannot be explained by the simple SN2 reaction. So for understand this, you can see how this is the mustard gas examples. Okay, so this is going to attack. After attacking, there is a formation of three-membered cyclic sulfonium ion. Three-membered cyclic sulfonium ion. So this three-membered cyclic sulfonium ion, which again attack by the another nucleophile. Okay, another nucleophile, thereby formation of this product. Okay, because the mustard gases having they are the primary halides which are rapidly undergoes the hydrolysis in presence of water. This is the reaction. You can see this is the neighboring group participation example. Water acts as a poor nucleophile here in this case. This water molecule acts as a poor nucleophile. Okay. So now see, this is the mechanism. What happened here? It is very clearly explained here. The lone pair from the sulfur, that is the atom, is from backside it attacks to the on the carbon on which your weak nucleophile or leaving group is attached, and this is the slow rate determining step. Slow step, that is the hence it is called as RDS, rate determining step, and this is called as an internal bimolecular nucleophilic substitution reaction, that is internal SN2 reaction. As first step, Always remember in NGP, the first step is RDS, determining step, as well as in first step, that is the internal nucleophilic attack takes place. That is the internal SN2 happening here in the first step, and hence after the attack you can see we have already seen in the previous slide, that is the how this your cyclic sulfonium ion is formed. Okay, so this in the first step we are getting the three membered cyclic sulfonium ion, which is going to attack by the water molecule or another base which is present in this reaction mixture, which is going to attack on your cyclic sulfonium ion. Now here what happened, this step is fast, and this is again the second SN2 reaction. Why it is second? Because first SN2 is already happened, taken place in the first step. Now in the second step, this is the fast step because this is a three-member cyclic sulfonium ion, three-member ring bearing the positive charge, having highly strained structure. So the even the weak nucleophile can facilitate this reaction, and you get the very fastly this product. So the rate of the reaction as compared to the normal nucleophilic substitution reaction, the rate of the NGP is the always higher. So the reaction in which nearby groups can evidently increases the rate of the substitution reaction. So for better understanding, uh, this is the chart you can see here. Always compare the SN1 SN2 reaction, okay, with this chart. So we have already discussed about the SN1 and SN2 reaction. Okay, okay. So in NGP is the first order reaction involving the successive two SN2 reactions. One is internal, that is the within the molecule, as well as the external from the outside the molecule. NGP occurs from a group that possesses an unshared pair of electrons or a double bond. NGP reactions are said to proceed by the neighboring group participation within the within the bonding distance only. Important characteristics of this NGP: the NGP enhances the rate of the reaction. Characteristic stereochemistry, that is the here not only retention but 100% retention of configuration. 100% here, 100% retention of configuration. Okay, so this is all about the NGP. So these are the examples. You can see that these are the examples of groups which can facilitate the NGP reactions. So simply the group having the extra lone pair, they can facilitate the or work as a NGP. So the most likely in NGP leads to 3, 5, 6 membered rings. So again I am repeating, that is the NGP is an intramolecular effect temporarily, that is the this is the temporary effect of the internal nucleophile. Okay, that internal nucleophile just assists the reaction, just speed up the reaction. Okay, so that even the weak nucleophile can also lead to the product. So this is the an intramolecular effect temporarily exerted by an adjacent group which directly participate by moving within the bonding distance. Don't forget this, that is the within the bonding distance of the reaction center, and again go back to the its original position. Okay, this is called as NGP. So there are two aspects of these NGP reactions. One is kinetic aspect and another is stereochemical aspects. So the neighboring group effects can be observed in the nucleophilic substitution reaction, and this neighboring group attacks the adjacent carbon atom with its electron pair, acting as a internal nucleophile. Right? This result in the simultaneous loss of living group. That is the reaction proceeding through the NGP would be unimolecular and several fold faster than one in which there is no NGP involved, as there is no NGP involved. And in this there is a formation of three-centered reaction bridged ion, right, which is an intermediate in this reaction. And another point that is the very important, that is the stereochemical aspects. The reactions proceeding through NGP involves the 2s2 reaction. So overall stereochemistry involves the 100% retention of configuration. So kinetic aspects, the internal nucleophile, which is also called as the migrating group, has apparently greater nucleophilicity than the external nucleophile. It means internal nucleophile should have the more nucleophilicity, more nucleophilic than the external attacking nucleophile. Second point, the internal nucleophile is oriented properly from the backside of the living group, okay, and which helps the or speed up the again the departure of the living group, so which helps the reactions takes place more easily. Okay, the NGP also helps to push out the living group, the reaction, and this is called as an antimeric assistance. And antimeric assistance, this antimeric, this is the Greek word anti means the neighbor, anti means neighbor, and mer means mer, okay, is a part, that is the neighbor part, that is the neighboring participation. In Greek it is called as antimeric assistance. Okay, next, an increase in the, because of this antimeric assistance, rate of the reaction in NGPs increases, and due to this antimeric assistance, the reaction accelerate, which is called as synartectic acceleration. Hence, reaction with NGP are characterized by the fast rate of reaction, and when the adjacent group with the lone pairs involved, then in the bridge ion, each atom has an octet. Hence, the bridged ion intermediate formed in NGP is the three-center reaction, which is the more stable than any normal intermediate. And as I say, that is there is no rearrangement is involved. There is no rearrangement is involved. Okay, because the migrating group or internal nucleophile is going to just assist the reaction, just it is going to help to the reaction for the departure of living group. Okay, so hence it is there is no rearrangement. So this is the another example. You can see sodium 2 bromopropionate, in sodium 2 bromopropionate you can see sodium lactate is formation. So this OH, one second. Okay, in this reaction you can see stereochemical aspects. Stereochemistry of NGP reaction is characteristically different as compared to that observed in the other simple nucleophilic substitution reactions. As in NGP, bridged ion formation taking place. The stereochemistry of NGP is also depends on the bridged ion intermediate formation and how it will react further with the external nucleophile. In NGP, there will be the 100% retention in configuration. You can see here this OH, blue OH is again the position of the nuclear OH is taken up by the Br, okay, which is written with the red color. So there is a 100% retention in configuration. So this is the again the same example. We have discussed this. retention. This is the mechanism, how this is the anti-periplanar position, how this internal nucleophile, that is the Br, is going to attack on this position. So there is a formation of three bridged ion bromonium cyclic structure, which is the highly unstable. Hence there are the two ways by which your Br minus, that is the external nucleophile, is going to attack from the, suppose this side, or from this side. Suppose the Br minus, this pink color arrow, it attacks through this side, so there is a formation of this product. And if the Br minus or nucleophile is attacking from this blue side, from this right hand side, we are getting this product, that is the mixture of plus minus 2,3 dibromobutane. Okay, so this is all about the neighboring group participation. So in summary, any system that has a nucleophilic substituent situated properly for backside displacement of leaving group at another carbon atom of the molecule can be expected to display the neighboring group participation. It may show the neighboring NGP. So reactions proceeding through the NGP can be identified by their enhanced rate of the reaction or increased in the rate of speed of the reaction, and characteristic stereochemical outcome is 100% retention of conjugation. So this is all about the NGP. Thank you.